So today we will be working on linear functions. So there are a lot of topics that is covered by linear functions, but today we will just look into two concepts, which is recognizing a linear function and graphing linear functions. So to begin, let us first define what a linear function is. And a linear function is defined by f of x is equal to mx plus b, where m and b are real numbers. So m and b are real numbers. Its graph is a line. The graph of a linear function is a line with slope m, so m is the slope, and y-intercept b. So b is the y-intercept. Now, if you have a certain linear function and you saw that m is not equal to 0, it can be any number except from 0, then the degree of the function is 1. If m is equal to 0 and b is not equal to 0, then the degree of the function is 0. But if m is 0 and then b is also 0, then the degree of the function is not defined. So let us analyze the definition one by one. So the standard form of a linear function is f of x is equal to mx plus b. I can also make f of x as y, because some of you have already seen this in your previous years. Y is equal to mx plus b. Both of them are the same. It's just that when we're dealing with linear functions, we use more of f of x. Okay? But again, it's still the same. The standard form of a linear function is f of x is equal to mx plus b. Okay? So this m and this b, both of them are real numbers. Okay? Particularly, m is the slope m, and b is the y-intercept. Okay, so that is what is meant by the definition of the linear function. Its standard form is f of x is equal to mx plus b. M and b are real numbers. Specifically, m is the slope. The slope is the rise over run. And then b is the y-intercept. This has been discussed with you in your previous year when you were in grade 7 or YSA. So this has been a topic, linear equation. But right now, we're looking at linear function. Okay? So what are the other parts of the definition? It says here that if for example, we have, if for example, we have y, or sorry, not y, if we have f of x is equal to mx plus b, and m is any number not equal to 0, then the degree is equal to 1. So, ibig sabihin, the highest exponent is 1. As you can see here, in f of x equals to mx plus b, the highest exponent of x is 1. Okay? If, for example, f of x is equal to mx plus b, and then m becomes 0, and then b is not 0, it's any number, the degree now is 0. Do you know why? It's because if m is 0, hindi na makikita tong mx. It will become 0 plus b. Therefore, the degree is 0 because there is no variable that has an exponent. Okay? I'll just erase this one so that it won't confuse you. Next, if for example, you have f of x is equal to mx plus b. M is 0. B is also 0. Then the degree is undefined. you cannot define the degree kasi everything is 0. Okay? So to further understand the, the definition, let's have two illustrative examples. So let's have example 1. Is the function f defined by f of x equals 2x plus 3 a linear function? If yes, determine the slope m and the y-intercept b. Okay, so let's see. According to our definition, a linear function has the form mx f of x equals mx plus b. So I will write it here. F of x is equal to 2x plus 3. So let's see if it's a linear function. So can you see here an m? Because the standard form for a linear function is mx plus b. So this is m, this is b, both are real numbers. So therefore, if we look here, the highest exponent of the variable x is 1. And m here, the m, is not equal to 0. Therefore, the degree is 1. Hence, it is a linear function. Remember, a linear function has the degree of 1. Okay? So, what is the slope? M. The slope m is the one beside the variable x, so that is 2. And what is the y-intercept? Y-intercept is the b, and that is equal to 3. Let's have another example. Is the function g defined by g of x equals negative x a linear function? If yes, determine its slope and y-intercept. Again, we write here, g of x is equal to mx plus b. That is the standard form. And what we have here is g of x is equal to negative x. Let's now look at the m and b. There's nothing written here but just a negative sign. What does it mean? This means that it is negative 1x. There is no b here, so if I put that, I can write plus 0. Right? So I have here negative 1x plus 0. Because b, there's no b in this question or in this function, so I can write here plus 0. Now let's look at this one. M is not equal to 0, right? Because m is equal to negative 1. So if m is not equal to 0, then what is the degree of this? The degree is 1, according to our definition. Even if b is equal to 0. Because in our definition, the degree will only be 0 if m is equal to 0 and b is equal to a number not equal to 0. Hence, this is a linear function. What is our slope? The slope m is negative 1 and the y-intercept, because there's nothing written, it is 0. So for this next illustrative example, again, we will be asked to determine the values of the function f if f of x is equal to 2x minus 1 at x is equal to negative 3, 0, and 2. We have to give their meanings and the ordered pairs. So I will write here again the function, which is f of x is equal to 2x minus 1. And if you observe, this is a linear function because, again, the highest exponent of x is 1. Okay, so this is the highest exponent. And then also m is not equal to 0. That's why this is a linear function. Now, we are asked to evaluate at x. What's the value if x is equal to negative 3, x is equal to 0, and x is equal to 2? This would mean the following. we are actually getting the value of f if x is negative 3. So we're getting f of negative 3, we're getting f of 0, and f of negative, f of positive 2. So to do that, we will simply substitute the value of negative 3, 0, and 2 to x. So let's start first with x is equal to negative 3. That means I'm getting f of negative 3. Hence, I will substitute negative 3 to x. So I will have 2 times negative 3 minus 1. And then I will solve. 2 times negative 3 is negative 6 minus 1. F of negative 3 is equal to negative 7. Okay, so this is the first one. Now, what do you mean by the ordered pair? We have learned that the ordered pair is the ordered pair xy. The value of x and then what is its corresponding value of y in terms of the relation and functions that we have. Diba? So, the ordered pair here is the value of x is negative 3 and the value of y is negative 7. So, this is now the ordered pair. Okay? Next, let us evaluate if x is 0. So if x is 0, it means I will solve for f of 0. And that would imply that I will change all the x's to 0. So I will have 2 times 0 minus 1. Again, this is our reference. This is our reference, this function. So we will have 2 times 0 is 0, so I can just cancel that, and then negative 1 will remain. So what is the ordered pair here? The ordered pair is 0, and then the value of y is negative 1. This is another ordered pair. Okay? Next, we now evaluate if x is equal to 2. That means we are getting f of 2. All the x's will be substituted by 2. So 2 times 2 minus 1. And we will have 4 minus 1, which is equal to 3. And what is the ordered pair here? X is 2, y is 3. This is another ordered pair. So why is it that we need this ordered pair? Again, this ordered pair is crucial for us to graph a linear function. So the ordered pairs will be used to graph a certain linear function. Okay? So what does this ordered pair means? It means that the function f, when x is equal to negative 3, has the value of negative 7. Moreover, the function of f of x has a value of negative 1 if the value of x is 0. And f of x is equal to 3 if the value of x is 2. Did you get that? So for practice, let us determine the different values of f of x as if x is equal to negative 3, x is equal to 1, and x is equal to 4. So the values that we are getting, we are finding f of negative 3, f of 1, and f of 4. So let's try first the first example, or the first question. F of x is equal to 2x. So if we solve for f of negative 3, we will have 2 times negative 3, which is negative 6. If we are getting f of 1, then it is 2 times 1, and then the answer is 2. If we are getting f of 4, that is 2 times 4, and then the answer is 8. Next, for number 2, let us have f of x is equal to 2x plus 1. So again, we're looking for f of negative 3. That means all the x will be negative 3. So 2 times negative 3 plus 1. I have here negative 6 plus 1, that is negative 5. If we have f of 1, that means it's 2 times 1 plus 1. And you will have 2 plus 1, which is 3. And lastly, for f of 4, that would mean 2 times 4 plus 1. 2 times 4 is 8, plus 1 is 9. So can you do number 3, 4, and 5 on your own? So how do we graph linear functions? So in order for us to graph linear functions, we have to have ordered pairs. So the ordered pairs will be the one that we will be plotting in the Cartesian plane in order for us to graph a certain linear function. So let's take the example that we have, previously. So let's have graph f of x is equal to 2x. Okay? So here, we have found out that if x is equal to negative 3, so f of negative 3, it's equal to negative 6. That's based on our computation a while ago. F of 1 is equal to 2, and if x is equal to 4, it is equal to 8. Again, for our ordered pairs, we put this in ordered pair form. X is negative 3, y is negative 6. No? That's the xy ordered pair. If x is 1, y is equal to 2. And if x is 4, y is equal to 8. So these are our ordered pairs. All of these are the ordered pairs. And this is what we will use in order for us to graph the linear function. Also, these ordered pairs can be placed in what we call table of values. So in a table of values, you can put here x on top and y at the bottom. Just separate it with a line and then separate or create different boxes for the different terms or ordered pair. So if x is negative 3, y is negative 6. If x is 1, y is 2. And if x is 4, y is 8. You can still add more values. It depends on you, on how many values you would want. But always remember, in our geometry last school year, that 2 points determine a line. And since we are having a linear function now, in order for us to graph a linear function, we have to have at least 2 points, okay, or 2 ordered pairs. So let us now put that in the Cartesian plane. Okay, so this is the Cartesian plane. We have the positive x-axis and the positive y-axis, the negative x and the negative y. So let us first plot the first ordered pair, negative 3 and negative 6. So x is negative 3, so I will put it here. So 1, 2, 3, this is negative 3. And then y is negative 6, so it is down here because it's negative. So 1, 2, 3, 4, 5, 6. So this is negative 6. So the intersection where they meet, that is where we will put the point. You already know this because we've done this in terms of plotting the points, right? Next, 1 and 2. So this is 1, positive 1, this is positive 2. So this is the point negative 3, negative 6. This is the point 1 and 2. Next, 4 and 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. So it's here. This is 4 and 8. And then all you have to do is to simply connect the points. Of course, it's better if you use a ruler. And now, this is now the graph of f of x is equal to 2x. So again, what we did here is we use the different ordered pairs. We gave values, no, random values for x, and then solved for y, and then plot that in our Cartesian plane. And then connect all the points with a line.